All right, welcome back to another Cultist Astronaut update. So today we're going to talk a little bit about texture atlases, sprite sheets, etc. They're all the same thing, um, and basically how we've implemented it into our engine. So on screen you can see here we have an example of what a texture atlas sprite sheet looks like, and basically it's just multiple sprites um, or multiple textures or regions of textures packed into a much larger texture. And these can be much larger than what you see here, but this is just an example of just one of the texture sheets we're loading into our game. Now, before this, we were loading each sprite in individually, and this was inefficient because instead of one texture, we have one, two, three, four, five, six textures, right? So when I exported all the sprites out of Unity, um, we had like almost 1,000 textures for all the objects, and now we're down to roughly 100, and we can confirm that real quick. If I go to you can see these are all the textures we're using, and this list is much smaller than it was previously. So if I go here and I scroll all the way down to the bottom of our asset file, you'll see we have 160 textures. So a little bit over what I was saying, but close enough. And some of these textures we're not going to even need, right? Like I'm exporting like the old Flayed King and some of the spawner graphics for the enemies, and these things aren't necessary, right? We're going to replace these with our own constructs. And then, of course, tiles are treated pretty much the same way, right? So a tile sheet is treated the same way as something like this. So how do we do that? In Unity, let me show you what Unity does. In Unity, if we go to one of these objects like this cathedral door, you'll see visibly this looks correct, and this is actually a PSD file, so Harlan was able to go in, create this door, and layer it the way he wanted to. But when we import it into Unity, what it does is it actually breaks it out into regions or subsprites. And each one of these has a name, a position, a width and height value, and then a pivot. So I can actually change the pivot for this object and the pivot for this object. And if I wanted to, I could resize the size of this region, etc. I think I can even do overlapping if I wanted to. Let me see if it lets me do that. It does. So and what this means is like when we go to render the quad, it's actually going to map these coordinates to the quad. So you'll actually see a part of the door and then this effect, right? Obviously this is all wrong, so let's revert that. And let's close this out. So that's how it works in Unity. And in fact, we can use the same data for our game engine. So if I go to the cathedral, let me see, what was it called? I might need to actually, let's see, cathedral door side. No, okay. Let me actually find the sprite in here. So there's a sprite sheet in here, and it should be the same as what we saw in Unity. It's probably right in front of me, and I just cannot see it. It should be grabbing the name. Here it is. Oh, I put an extra underscore. So if we search for this file, you'll see it's entry number 25. It's a texture. It maps to this. We have the same pixel per unit value and pivot. So this pivot's actually the global pivot. So if we go back into Unity and I open this up, this whole sprite should have... No, okay, they kind of hide it, but in the actual meta file that's associated with textures, there is a document pivot, and I believe that's associated with this entire texture. We still store it. I may end up removing this because let's say we do have a texture and there's only one region, we can still represent it as one region, right? So down here you'll see this has 11 regions, and then we have the data for each region packed into here. So for example, if I scroll down, we'll find the If I can find it. Should be a door frame here. Oh, it was right in front of me. Door frame back, right? And you can see it says 4, 4, and then this is actually half width and half height. So this will be double in Unity. But if we go into Unity and we compare this, you'll see it's 4, 4, 223, and 477. 223, 477, that's double 111.5 and 238.5. So we're exporting these values out of Unity. Later on, when we make our own editor for these things, we can make exactly what you see in Unity, where you can basically map out the rectangles. So that's cool. We're able to like export those out and basically define where in pixels where each region is. Now, of course, when we go to render this, we have to convert these rectangles into UV coordinates. And so if we open up like, let's see, a little document here. Actually, let me use a different tool. I've been using something called Milton for drawing. So let me just pull that over, and then looks like I have some stuff from earlier. So let me just erase all of this. And then let's talk about coordinates. So what we were doing before is we had our triangle rendered as such. Right, we have our two triangles. So every sprite in our game, since we're 2D, is just a quad. And we can render a character to this quad, or anything really. Like our saw blade can like fit inside of this, and then we have like the transparent edges, right? And typically, let's see, if I might be messing this up. The order is important, but let me just write this out. So typically we have something like this. And I believe in DirectX you have to go this way. So when I write this out into the GPU, I say, hey, here's the vertices, right? I have like a list of vertices where it's like this is 1, 1. This would be 1, 0. And I'm mapping it to these, right? And then we have 0, 0. Oops, did that wrong. 0, 0. And then we have 0, 1. And again, I might have this all messed up, but it's something I tweak on the GPU side. And then OpenGL is like reverse. I think you can change that as a setting. It's fun. But the concept here is still the same. So basically, we have these 4 vertices, and then we map them using the indices. So we say, okay, I want to draw this triangle. And then I want to draw this triangle, which would be, I think we could just do 2, 3, 0, right? And so we send this and this. So this is what you would call our vertex buffer, has our vertices, right? And then you have our index buffer. Now we also want to be able to map UVs to this. UVs are our texture coordinates. And so when we look at something like this, we basically want to take the corners of this image and map them onto this quad. So we also have UVs, and there's different ways you can map these. You can actually append them here if you want to like associate a UV with each vertex buffer. I'm currently taking a different approach because I use the same exact quad geometry. So I'm like using the same exact vertex buffer for all sprites. And that means that I can't stick the UVs onto the end here because the UVs change per quad. So I actually have a different buffer for UVs. And in here, I would actually upload the normalized values, right? So what we saw before was it was like 4, 4 for the X and Y. And then we had the width, which was like, just for simplicity's sake, I'll say 200 and 300, right? And so what this tells us is that if we have a sprite sheet, I'm going to draw this miniature version here. Basically, 4, 4 is like right here. And then 200 out. And then 300 up. And then this is our quad. So this is our entire texture. And this is our region that we want to map to this, right? And so we actually, map it. We go, okay, put that here, put that here, etc. And then we generate a list of UVs. I'm not going to do the math here because I'll show the code, but basically we have 4 UV values that we map to this, and then the index buffer still uses these correctly, right? So it'll say, hey, grab 0, grab 1, grab 2, and this will say grab 2, grab 3, and grab 0, right? And this will line up perfectly with the vertex buffer. And of course, if I want to render a different region, we have different values, right? I could say, okay, I want to grab this region over here, and now I want to map this to the quad. So then we update the UV buffer with these values, and then the GPU will be able to map that correctly. That's just a little visual diagram there of how that works. Let's jump into the code. So like I said, here's the math for converting pixel coordinates to normalized values, which is what we typically work with in the graphics side. We have a value from 0 to 1, 0 being the bottom corner of this texture, and then 1 being the top corner of the texture. And so then if we wanted to get like this value, this would be like 0.05 to 0.4, for example. So that's like about 40% of this texture. So think of normalized UVs as just a percentage of the texture size. And so in order to get the percentage, we basically divide by the width. And so this entry width here, this entry is actually the texture size. And then if we look here, we also calculate the width and height of the region. And so X and Y are easy. We just take the X and Y coordinate, divide it by the width of the PNG and by the height of the PNG, and this gives us a percentage value, which is perfect. That's 0 to 1. And then down here, we actually have to convert our width to a pixel coordinate. So we take the X plus width. So that's an offset, right? If we were to look at it here, that's like taking the X here and then adding the width. So we get like this position. And then we divide that by the width. And we do the same thing for height. We convert this to a pixel coordinate and then divide it. And now we have normalized coordinates. Now, before we actually assemble the coordinates, we have to invert them and we have to invert them on the Y, because when I load the PNG in, that's hard to say, the PNG starts up here at 0, 0, but DirectX is down here at 0, 0. So we have to invert the Y. And inverting is easy. We just have to subtract, we just have to take 1 and then subtract it by V start, and same for V end, and this will invert the coordinate. So if it's like 0.5, well, 1 minus 0.5 is 0.5. If it's 0.25, then it will be 0.75. And that inverts it. That flips it across the y-axis. And then down here, I assemble the coordinates. So I take the x and y's and I put them in all the right orders. And then, like I said before, the order matters here. So this is our 0, 1, 2, 3, which lines up with what we drew over here, right? 0, 1, 2, 3, which will be mapped to each coordinate that we see on the triangle. Perfect. And then, of course, I'll show a little bit of the code over here. So I am reading these in from the file. So when I read the asset file, so this line right here maps to what we see here. So you see this is a texture. And so if the type is a texture, then we import the pixel per unit. We import the pivot. And then here's the region count. And then, of course, we loop through and we grab all the regions based on the count. So we do a while loop, and then we grab everything we need. I just learned recently that you don't need to do / tab, but we'll find out in a second because I'm going to hit play. I learned recently that scanf will actually ignore white space in front of the thing you're scanning. And yeah, that should all line up with what we see in this file. So what does this look like? Well, I exported the entire world of Excorious. So if we scroll down, this is quite a big file. You can see there's like hundreds of thousands of lines of text. And every one of these is a sprite component. So there's not anything fancy going on here yet. I don't have any entity grouping or hierarchy. This is just a flat list of entities that we're just loading in. And of course, it's not even optimized yet for like render batching. Like we're not even doing a proper batching system for for textures. And it looks like you know what, for now I'm not gonna screw with this because this did work. And it looks like it's crashing now, so we're just gonna do that. Let's do that again. Yeah, it looks like it's working. Okay, cool. So let me pull this over. So here is everything being rendered with the new texture system. So this is really nice. Like let's just pick something. So like for example, this right here is a multi-layered sprite object, and I can show you that by going into the sprite and showing you what it actually looks like in texture form. So if we go down, we can find the ship. There's actually two of them, so that's a question mark. We have the flat grasshopper, and then we have the broken up one. So yeah, you can see here, like these are all the individual pieces of the ship. And again, we're not doing this in the most optimal way. Obviously, there's a bunch of dead space up here. And so preferably like you have something that's tightly packed like this so that you can minimize the amount of textures you're loading. I'm just exporting these out of Unity, and Unity's doing its own thing with the Photoshop files. But again, we can take this a step further and really pack these tightly together. But you can see this is like the individual pieces. And then the door we looked at earlier, which should be all the way, let me see, all the way over here. Yeah, the door we were looking at, you can see it's being rendered correctly. We have this butcher guy standing in the way, so let's go to this one. But yeah, this looks exactly like what we saw in Unity. So the same exact graphic, just flipped on the x-axis. And this one has a lock icon too, which is kind of cool. I'm glad that came in. And it's really important that we render this in the correct order as well. So every one of these sprites has a sorting order and layer, which allows us to like essentially dictate how far back a sprite is rendered and then how far forward a sprite is rendered. So this saw handle always renders above the door frame, even though you know it's a different object in the texture. It's actually the same, but oh no, these are different. You can see it's the same texture sheet, but it's a different sprite within that. And so when we assemble this in the file, in the Xcoria world file, we have to specify the sorting layer and sorting order. I did a video on this previously, so you could check that out, how we did this. But yeah, that's what I've been working on. I've added the texture atlas system, and I made a way for us to associate it with an entity. Yeah, as always, if you have any questions or feedback, feel free to leave a comment below. Have a wonderful day.